Hello everyone and welcome to our first class on data structures and algorithms, commonly known as DSA. This course is for B.Tech third semester students of CSE, IT and AI and ML. Now think about this for a moment. How does Google Maps find the shortest route? How does Google search through billions of web pages? How do modern AI systems handle huge amounts of data? Behind all these applications, there is an important concept, data structures and algorithms. That is why DSA is often called the heart of computer science. In this course, we will learn how to organize data, solve problems efficiently, design better algorithms, and improve our logical thinking. And remember one important thing, don't just learn to write code, learn to think about how to solve a problem in a smarter way. Now let us understand why data structure is so important. Data structure and algorithms helps us answer some simple but important questions. How do we store data efficiently? How do we process it faster? And how do we solve a problem step by step? And most importantly, how do we choose the best solution? As you can see, DSA is all about organizing data or designing algorithms, choosing the right approach, and improving performance. That is why DSA forms the foundation of subjects like DBMS, operating systems, AI and ML, networks, compiler design, and data mining. So remember this, DSA is not just about writing code, it is about thinking smart and solving problems better. With a strong DSA foundation, you can build much more on top of it. Now let's see what exciting things are going to learn in this course. Now let's see what you will learn actually in this course. By the end of this course, you will understand different data structures and learn how to choose the right one for a particular problem. You will study linear data structures like arrays, linked lists, stacks, and queues, and non-linear data structures like trees, graphs, and heaps. You will also learn how to analyze algorithms, compare their efficiency, and understand important searching and sorting techniques. But the most important outcome is this. You will learn how to look at a problem, think logically, choose the right approach, and solve it efficiently. So, this course is not just about learning concepts or writing programs. It is a journey from understanding the basics to becoming a confident problem solver and efficient developer. Let's begin that journey step by step. Why study DSA? Now let us understand why DSA is so important. Imagine two students are asked to search for a number from 10 million records. Student A uses linear search while student B uses binary search. Interestingly, both programs give the correct answer. But look at the difference. Student A takes around 15 seconds while student B takes only around 0.02 seconds. So both solutions are correct, but one is much more efficient, and this is one of the main reasons we study data structures and algorithms. DSA helps us find not only a correct solution or correct strategy or correct data structure, but also an efficient solution, that is efficient algorithm to solve a particular problem. Now you may ask, does the execution time always remain the same? Not necessarily. The execution or running time of a program depends on factors such as processor speed, memory, and machine configuration. So the same program may take different amount of time on different computers. Here, for a simple comparison, we assume that both students run their programs on machine with the same configuration. But in DSA, we want a more general way to compare algorithms, one that is independent of a particular machine. This is where algorithm analysis comes in. We analyze how an algorithm grows as the input size increases using asymptotic notations and concepts such as time complexity, base complexity. So the main lessons from this example is writing a program that works is good. Writing a program that works efficiently is even better. And that is what DSA is all about, choosing the right approach and solving problems smarter. Before we go deeper into data structures and algorithms, we need to understand the basic difference between data and information. What is data and what is information? Look at these numbers 65, 85 and 92. What do these numbers mean? At this point, we don't know. They are just raw facts or figures without any context. This is called data. Now, suppose I tell you Rahul scored 85 in mathematics, 90 in physics and 88 in chemistry. Now the numbers have meaning. They tell us something about Rahul's performance. This is called information. So in simple words, data is raw and unorganized, information is processed and meaningful data. In computer science, we collect data and organize it, process it and transform it into useful information. And this is exactly where data structures become important, because to process data efficiently, we first need to know how to organize it properly. Now let's move ahead and understand how data structure help us organize data. Now we know or understand the difference between data and information. The next question is, what is data structure? In simple words, a data structure is a systematic way of organizing and storing data so that we can access and modify it efficiently. Let us understand this with a simple example. Imagine all your clothes are thrown randomly on the bed. If you need to find one particular shirt, it may take several minutes. But now imagine your wardrobe is properly organized, shirts in one section, pants in another, shoes in their proper place. Now finding a shirt takes only a few seconds. This is exactly the idea behind a data structure. The same data, when properly organized, becomes easier and faster to access. In computers, also data may be huge. If it is not organized properly, searching and processing it can take more time. A good data structure helps us save time, improve efficiency, and achieve better performance. So remember, a good data structure organizes data in a smart way, making it easier to access, modify, and process. And throughout this course, we will learn different ways of organizing data and understand which data structure is best for which problem. Now let us make DSA even more interesting by connecting it with real life. Data structures are not just computer concepts. In fact, similar patterns can be seen all around us. For example, think of books organized on a shelf. This is similar to an array where elements are stored in an organized sequence. Now look at train coaches connected one after another. This is similar to a linked list where each element is connected to the next one. A stack of plates is a perfect example of a stack. The last plate placed on the top is the first one removed. This is called LIFO, last in first out. Similarly, a queue at a bank follows FIFO, first in first out. A family tree represents a hierarchical structure, just like a tree in computer science. And finally, Google Maps, where different locations are connected by roads, is a good example of a graph. So, as we move through this course, try to connect every data structure with real life example. Once you understand the concept, you will start seeing data structures everywhere. And that brings us to the end of our first DSA lecture. Today we explored the basics of data structures and algorithms, different types of data structures, the role of algorithms, efficiency, and real life examples. Remember, good programmers write code, but great programmers choose the right approach. In the next class, we will explore what is an algorithm. We will see real life examples, understand the relationship between data structures and algorithms, and discover why data structure is so important. So stay tuned.
Full slides in the description of the next video. If you enjoyed this lecture, like the video and subscribe to Infinite Tech Study for the complete DSA lecture series. Keep learning, keep practicing, and keep growing. Thank you for watching, and see you in the next class.